Good morning. This is Kristen Parkinson and Joseph Hughes, part of Group 8, and we'll be going over Chapter 18, Create, Review, and Coordination Process to increase the quality of our current work. We learned, as in previous chapters, that by developing a high level of trust and not relying on approvals of external teams, we can speed up the development process. All too often, those who are over the approval process are far too removed from the initial code, and they may take too much time in the approval process, which ultimately affects the lead times. We'll learn about the process in GitHub, where developers can initiate a pull request, which garners reviews from fellow dev and ops. Additionally, through the collective set of practices called GitHub Flow, developers can gather reviews, request free feedback, and announce deployments, seemingly seamlessly in reviews, feedbacks, and the approval process, and all of which is being simultaneously documented. And finally, breaking the bureaucratic red tape process, which slows down the value stream. The Knight Capital deployment accident is an example of how low trust environments needing higher and higher approvals by individuals far removed from production almost technically destroyed a company. There was a change control failure which could have been prevented if there had been better practices to prevent risky code being pushed in production. The accident was due to testing failures. If they had had better testing practices, this could have also been caught earlier. And finally, if they had better methods of telemetry to identify the problems quicker, they may have been able to stop it. But all of this happened within 15 minutes, costing the company millions of dollars, and essentially the company was sold over the weekend. Now, potential dangers of overly controlling changes. Longer lead times are increased due to the additional questions needing answering, requesting more and more authorization to initiate the change. These controls can add friction, which lower trust levels, which snowball into higher batch sizes, which are usually more risky and take longer to diagnose problems, all compounding the problem. Change advisory boards serve as important roles in coordinating and governing the delivery process, but should not be manually evaluating each change. The Toyota production system model shows us that people closest to the problem typically know more about it. In DevOps, relying on approvals from individuals further away from the process reduce the likelihood of success. Using peer reviews increases IT performance, and this stems back to the high trust and collaboration between peers. Enable coordination and scheduling of changes. Now, depending on the size of the organization, the type of system architecture, we may need to coordinate the schedule of changes in order to minimize the possibility of accidents. This can be achieved with chat rooms or even the GitHub Flow model to announce changes or push into production. With global infrastructures, this process is very important, along with redundancies and comprehensive testing. In tightly coupled architectures, this is especially needed where small changes can disrupt production. With loosely coupled architecture, the communication and coordination is more autonomous and less likely to disrupt other teams, but communication and documentation are still very important. Enable a peer review of changes. By using peer review of changes, it improves the quality of code, it offers cross-training and peer training, and improves everyone's skills. Should further review be required due to team-wide or global impact, this can be requested. Making batch sizes smaller and easy to review helps simplify the process into work. The process requires that, number one, all code be reviewed before committed to a trunk. Number two, monitoring commits downstream, as discussed in previous chapters. Number three, identifying high-risk changes which should require further review. And number four, breaking up changes into smaller batch sizes. These code reviews can be completed in 4 review options, either by pair programming, where programmers work in pairs, doing the over-the-shoulder, where one developer looks over the author's shoulder as the latter walks through the process of the code, explaining the process and his thinking process through it. One is email pass around. The source code management system emails code to reviewers automatically after the code is checked. This is kind of like how we do the peer review here with others' presentations in the class. And the last one is tool-assisted code review. We use tools designed for peer reviews like the GitHub pull request, Gerrit, or other source code repositories. We learned about the case study, the code review at Google. So sometimes Google's testing examples shows how lead times are affected by the change sizes. In the graph, it shows that if the code is smaller in size, the quicker approval it gets. The larger the code batches get, the longer it takes to approve. Sometimes testing countermeasures can fail. If we're merely performing more and more testing when testing failures occur, we may be worsening our outcome. Manual testing is slower, which can slow down development. By integrating our daily work as part of the flow of production, this can increase deployment frequency. Potentials of doing more manual testing can cause change freezes. Now enable pair programming to improve all of our changes. So pair programming is where two engineers are at one station. One is the driver, and he is the one who actually writes the code. He's more specifically, the driver is free to focus on all of their attention on the tactical aspects of completing the task. The other engineer acts as the navigator, the observer, or the pointer. This person who reviews the work as it is being performed. The navigator may also consider the strategic direction of the work, as well as coming up with improvements and addressing likely problems. While this process might feel invasive, and slowing performance by as much as 15%, the end result is up to 85% error-free code, which is a substantial savings in technical debt. As stated earlier, this also results in cross-training, peer learning, and skill improvement. Evaluating the effectiveness of pull request process. We can evaluate the effectiveness of pull requests by reviewing them. What sort of detail did they give? If there's no detail or context as to what the request is intending to do, it's probably a bad pull request. A good pull request asks for appropriate review. It has sufficient detail on why the change is being made and how they are being made, as well as identifying future risks and resulting countermeasures, part of thinking about the value stream. Now, fearlessly cut bureaucratic process. One metric is to see how many meetings and work tickets are mandatory to perform a release. If the approval process significantly increases the lead time, the process should be reevaluated. Don't be afraid to evaluate the approval process. Now, Heather Mickman, the Director of Development at Target Inc., asked the 5 whys when trying to understand the long approval process for changes. Upon evaluation, no one exactly knew why or what prompted the long approval process. It was eventually dismantled based on success that she had with her own team. She led it by example in having her team be responsible for service support, as well as integration, availability, and security. In conclusion, in this chapter, we learned about how to build a culture of high trust and why that high trust is needed, how working in pairs can reduce errors, how to use communication and scheduling to optimize the flow, and evaluating quality, not quantity, of pull requests, and how to reduce the red tape. So let us know if you have any questions, and thanks.